Starship's seventh flight commenced successfully at 4:37 p.m. CST, showcasing a smooth ascent. Initial telemetry data confirmed the successful operation of 33 out of 33 engines. The vehicle reached supersonic speeds within minutes, successfully passing through Max Q, the point of maximum aerodynamic stress. Ground crews performed crucial manual checks on various systems, contributing to the initial success of the launch. This proactive approach to monitoring and managing critical systems highlighted the collaborative nature of the mission's execution. The hot stage separation, where the booster engine reignited, also proceeded according to plan. The initial phase of the mission was met with enthusiastic support and applause from the launch team. The vehicle's arc into the endless blue sky provided a spectacular visual display, showcasing the power and precision of the launch system. These early stages of the mission proceeded without major setbacks, setting a promising tone for the remainder of the flight. The early data signals a strong start for the mission. Starship boosters return and catch, a major triumph for reusability. The successful return and controlled catch of the Super Heavy booster were a pivotal moment in Starship Flight 7, showcasing SpaceX's advanced capabilities in reusable rocket technology. The booster's return burn, initiated by the ignition of 12 of 13 gimbaled engines, showcased the precise control achieved during the descent. The ground control confirmed a go for booster return, signaling the successful navigation of the booster back to its designated landing zone. This precision landing maneuver demonstrated advanced piloting and control systems, indicating a crucial step forward in the development of complete rocket reusability. The booster's return and subsequent catch by the launch tower's mechanical arms emphasized the sophistication of SpaceX's system. This second successful catch, using the same launch tower and landing pad, further validates the reliability and precision of the booster's guidance system. The control and precision required to guide a massive booster back to the launch pad demonstrated the technological sophistication and extensive testing that has gone into the design and development of the system. The seamless execution of the return burn and subsequent catch was met with great enthusiasm and marked a significant milestone in reusable rocket technology. This precise maneuver was a testament to the engineering and logistical prowess behind SpaceX's mission. Starship's loss during Flight 7, a setback in the mission's ambitious goals. Despite a successful booster recovery, Starship Flight 7 encountered a significant setback with the loss of the spacecraft itself. Contact with the spacecraft was lost approximately 8.5 minutes into the flight, shortly after the main engine cut off. This unexpected loss of communication prompted immediate investigations into the cause. The precise reason for the loss remains uncertain, and the analysis will require a thorough review of gathered data from multiple sources. SpaceX acknowledges that data analysis will take time, and the investigation into the cause of the loss will be critical for future missions. The setback serves as a reminder that even successful initial phases of a complex space mission can be followed by challenges and failures. SpaceX is committed to a thorough investigation and will utilize the findings to improve the system and ensure the safety and reliability of future Starship flights. This is a crucial step in understanding and addressing potential issues within complex systems like Starship. The loss underscores the fact that even experienced teams in the space industry encounter difficulties in highly complex and experimental projects. The team is committed to learning from the incident and using the results to develop more robust and reliable systems in future Starship projects. SpaceX's transparent approach to acknowledging the loss and initiating a thorough investigation is key to ensuring the safety and success of future missions. Starship upper stage lost on 7th test flight, debris seen spewing in sky. Rocket debris from a SpaceX's Starship Super Heavy booster was spotted in the sky after a rapid, unscheduled disassembly before part of the device successfully returned to its chopsticks for a second time. The vehicle lifted off from SpaceX's Starbase test site at Boca Chica, Texas. The booster then separated about 2 minutes and 45 seconds after liftoff and headed back towards Starbase, Space News reported. The spacecraft's 6 engines appeared to shut down one by one, with contact lost just 8.5 minutes into the flight, SpaceX said. Starship experienced a rapid, unscheduled disassembly during its ascent burn, SpaceX said in a statement. Teams will continue to review data from today's flight test to better understand root cause. With a test like this, Success comes from what we learn, and today's flight will help us improve Starship's reliability. It was the 7th test flight for the powerful rocket. The spacecraft was supposed to soar across the Gulf of Mexico from Texas on a near loop around the world, similar to previous test flights. It was packed with 10 dummy satellites for practice at releasing them. It was the first flight of this new and upgraded spacecraft. It was great to see a booster come down. But we are obviously bummed out about Ship, said SpaceX spokesman Dan Hewitt. The Federal Aviation Administration, FAA, told Fox News Digital that it was assessing the operation. The FAA is aware an anomaly occurred during the SpaceX Starship Flight 7 mission that launched from Boca Chica, Texas, on January 16, the agency said. The FAA briefly slowed and diverted aircraft around the area where space vehicle debris was falling. Normal operations have resumed. The last data received from the spacecraft indicated an altitude of 90 miles and a velocity of 13,245 miles per hour. The 400-foot rocket had thundered away in late afternoon from Boca Chica, near the Mexican border. Elon Musk said he plans to launch actual Starlinks on Starships before moving on to other satellites and, eventually, cruise. NASA Administrator Bill Nelson congratulated SpaceX while noting that spaceflight is not easy. It's anything but routine, he wrote on X. That's why these tests are so important, each one bringing us closer on our path to the moon and onward to Mars through. Falcon 9 launches dual lunar missions, underscoring SpaceX's expanding lunar role. In a separate but equally significant event, SpaceX launched a Falcon 9 rocket from the Kennedy Space Center, successfully deploying 2 lunar spacecraft. This mission highlights SpaceX's expanding role in lunar exploration, complementing its ongoing Starship program. The launch deployed Firefly Aerospace's Blue Ghost lander and Japan's Resilience lander, marking separate missions focused on scientific research and technological advancements. The launch underscores SpaceX's burgeoning contributions to NASA's Commercial Lunar Payload Services program, indicating a broadening scope of activity beyond its primary focus on Starship. The Blue Ghost lander, designed for a 25-day Earth orbit before heading to the Moon for a 16-day lunar orbit mission, is equipped with 10 NASA payloads. These payloads focus on studying the Moon's magnetosphere dynamics, and the mission aims to offer valuable data about the lunar environment. This meticulous approach to lunar science aligns with broader international and national efforts to explore and understand the Moon. The Resilience lander, with a slightly longer trajectory, 4 to 5 months, will deploy a small rover for soil and rock sampling, a critical step in understanding the composition and potential resources of the Moon. Its mission also tests essential lunar communication and power systems. This intricate and comprehensive mission, alongside the Falcon 9's successful deployment, confirms SpaceX's capacity for handling complex lunar missions, setting the stage for potential future collaborations and research initiatives. The successful completion of this mission further solidifies SpaceX's place as a key player in the expanding field of lunar exploration. China's sea-based rocket launch, a strategic shift in space operations. China's recent launch of its Long March 3 or Smart Dragon 3 solid rocket from an offshore platform near Haizhou City in Shandong Province marks a significant strategic shift in its space program. This sea-based launch, the 5th of its kind for the Long March 3 rocket, reflects China's growing ambition to compete in the commercial space sector and reduce costs associated with traditional land-based launches. This represents a substantial change in strategy, emphasizing the advantages of offshore platforms, including shorter preparation times and potentially more cost-effective services for satellite customers. The launch vehicle, the Long March 3 or Smart Dragon 3 solid rocket, has a carrying capacity of 1.6 tons, carrying a payload of 1.6 tons to a sun-synchronous orbit. This successful mission underscores improvements in the rocket's performance and capacity, with plans to further enhance the rocket's capabilities to potentially reduce launch costs and increase payload capacity to roughly 2 tons. This reflects a calculated move to streamline space operations, potentially attracting more commercial clients. China's emphasis on sea-based operations signifies its intention to compete with established space powers like the United States, particularly SpaceX. The nation has ambitious plans for 10 sea-based launches in 2025, building on last year's 6. This strategic shift in launch operations signals China's intent to challenge existing dominance in the commercial space sector. Despite this ambitious goal, the long-term impact of this strategy compared to SpaceX's extensive launch program remains to be seen. Global momentum in space exploration, Falcon 9, Starship, and China's advancements. This week's space launches underscore the accelerating momentum in global space exploration. The combined efforts of nations, including China, and private companies like SpaceX, are propelling us into a new era of exploration. The successful Falcon 9 launch, with its dual lunar missions, showcases SpaceX's expanding capabilities and expertise in lunar missions. Simultaneously, China's offshore rocket launch underscores its commitment to space development and commercial endeavors. These concurrent events demonstrate the escalating competition and collaboration driving advancements in the field. The launches highlight the growing global interest in space exploration, with nations and private companies actively competing and collaborating to push technological boundaries. The moon, once a distant aspiration, is now a more accessible frontier. This surge in activity reflects increasing accessibility and reduced cost associated with these operations, potentially opening the sector to further commercial participation. The intertwined trajectories of SpaceX's Starship program and China's Long March rockets illustrate the parallel and converging ambitions of global powers in space. These recent achievements in space exploration are not just isolated events. They are part of a broader global trend, with significant implications for the future of space travel and colonization. The interconnectedness of these developments signifies a growing global investment in space exploration, promising even greater advancements in the years to come.